You've probably heard the term DevSecOps thrown around. And yeah, it can sound pretty complicated. But honestly, it's the secret sauce behind how your favorite apps are built to be both amazing and, most importantly, safe. Today, we're going to break down exactly how it all works, nice and simple.
I mean, think about it. When you buy something online, you're handing over your personal details, your credit card number. You're trusting that app. So how do companies make sure that trust isn't broken? Well, the answer is a really powerful idea that has totally changed the game for how we build software.
The heart of it all is this infinity loop you're looking at. It's a non-stop cycle of creating, protecting, and improving. You see, in DevSecOps, security isn't some final step you do at the end. Nope. It's woven into every single part of this loop, right from the very first idea to the final product and everything after.
So here's our game plan. First, we'll get into why putting security first is such a huge deal. Then we're going to walk through the two halves of that loop, the dev side, which is where we build stuff, and the ops side, where we run it. And finally, we'll boil it all down to two golden rules you'll definitely want to remember.
Okay, let's kick things off with the main idea. What does it really mean to have security right from the get-go?
DevSecOps is just a mashup of three things. Development, that's building the software. Security, protecting it. And operations, running it. But the real key word here is culture. It's all about breaking down the walls between these teams and making safety a shared goal from day one.
Think about it like this. In the old days, with just DevOps, the main goal was speed. Go, go, go. Teams would build a whole app, and only at the very, very end would they throw it over the wall to the security team. With DevSecOps, security isn't the final boss battle anymore. It's more like a helpful teammate who joins your quest from the very start.
All right, let's make this real. Imagine we're building a brand new online shopping mall from scratch. The first half of our loop, the dev part, is all about designing and actually building our store.
Every great project starts with a plan, right? In this stage, we're basically the architects. We're drawing up the blueprints for our mall, figuring out what features it needs, like a search bar, a shopping cart, and of course, a way for people to pay.
And right here, at the blueprint stage, our security expert steps in with a tip. Think about safety now. We decide from the jump that all customer data has to be private, and all payment info needs to be scrambled with strong encryption. It's so much easier than trying to add security vaults after the mall's already built, right?
Now the construction crew, our developers, gets to work. They take those blueprints and start writing the code. Think of it as the digital bricks and mortar that'll bring our shopping mall to life, building everything from the search bar to the checkout counter.
And here's the next security tip. As our developers are writing code, they use these amazing tools that act like a super smart spell checker, but for security. These tools are automatically scanning for common bugs and weak spots, helping the developers fix them right there, long before they become a real problem.
In the build stage, we take all those individual pieces of code and we put them all together. It's kind of like assembling all the pre-made walls, windows, and doors to create the actual structure of our mall. For the first time, it's starting to look like a real app.
Now, we didn't make everything from scratch. We used some pre-made parts, maybe like door locks or window panes from other companies. In the software world, these are called open-source libraries. So the security tip here is to use an automatic scanner to make sure all these third-party parts are safe and don't have any known security problems.
Before we open our mall to the public, we have to test it. We run through every single scenario. We check if the lights turn on, if the door is open, if the cash registers work. In our app, we're making sure every button and feature does exactly what it's supposed to. But we don't just test if it works, we test if it's strong. We basically hire a friendly hacker, which is really an automated tool, that tries to break into our app while it's running. It'll rattle the doors, check the windows, and look for any weak spots a real thief might try to use.
Okay, our mall is built and tested. Now it's time for the ops loop. This is all about opening our store to the world and keeping it running smoothly and safely, of course. The app has passed all its inspections with flying colors, so the release stage is kind of like the ribbon-cutting ceremony. We package everything up, give it a final polish, and get it ready for the big day. It is officially approved for launch.
But before we cut that ribbon, our security expert has one last tip. Do one final check. We run one last super thorough security scan. This is our last chance to catch anything we might have missed before actual customers start walking through the doors.
And it's time. The deploy stage is the grand opening. We officially open for business by moving our application onto the live servers, making our online shopping mall available to everyone on the internet. Let's go!
The expert tip here is to lean on automation.
We have scripts that set up all of our servers with the correct firewalls and security settings automatically. This means there are no human mistakes, and every part of our setup is secure from the second it goes live.
This stage is all about the foundation itself. You see, in the modern cloud, we don't build servers by hand. We actually create them using code. This is something called infrastructure as code. It's like having a master blueprint for our entire mall's foundation, which we can use to build a perfect identical copy anytime we want. The security tip for building this foundation is a classic: the principle of least privilege. It sounds fancy, but it's really simple. It just means every employee and every system in our mall only gets the keys to the rooms they absolutely need to do their job. A cashier can open their cash register, but they can't get into the main security office. This really limits the damage if something goes wrong.
Okay, our mall is live and it's buzzing with customers. But our job isn't over. Not even close. The monitor stage is all about watching what's happening 24/7. We're watching the security cameras, checking for crowds, and making sure everything is running just right.
And for our final stage, the security expert's tip is to have a high-tech security system. This system watches all the digital camera feeds in real time. If it spots anything suspicious, like someone trying to pick a lock, it doesn't just ring a bell. It can automatically lock that door and alert the security team, stopping threats before they even get started.
So we've made it through the entire loop. I know that was a lot to take in, but it all comes down to two simple, really powerful ideas. These are your golden rules for DevSecOps.
Golden rule number 1 is shift left. If you look at our loop as a timeline, the earliest parts, like plan and code, are on the left side. Shifting left just means dealing with security as early as you possibly can. And why? Well, fixing a mistake on a paper blueprint is super cheap and easy, but trying to fix a crack in the foundation of a finished skyscraper? That's a total nightmare.
And the second golden rule, which is honestly the most important one, is about a change in mindset. Security is no longer just the security guard's problem. In a DevSecOps world, the architect, the construction worker, and the store manager, everybody shares the responsibility for keeping the mall safe. It really is a team sport.
So that's DevSecOps in a nutshell. Building security in, not just bolting it on at the end. But as technology changes, this loop is going to change too. With AI tools now writing more and more of our code, it leaves us with a pretty fascinating question. How do we keep this cycle secure when the developer might not even be human? What new security checks will we need for our AI teammates? Definitely something to think about. Thanks for tuning in.